All right, so today we are going to be moving on into Chapter 3. The first part of Chapter 3 with 3.1 is working with mathematical expressions. So a big portion of Chapter 3 is going to ultimately be culminating into working with a lot more story problems, a lot more word problems with all of this material that we are working on. So I think I've said it a few times before leading up to now, but it's going to be even more apparent and it's going to come up a heck of a lot more now, translating English into algebra. So this page that I've referenced I don't know how many times now is going to be absolutely vital if you are struggling with, or you end up struggling with this material. It's very important to have this nailed down for this chapter. So I think the big part with translating these things, whether it be in 3.1, whether it be in chapter 4, chapter 5, you go on into pre-calculus, multivariable calculus, whatever it may be. If you are translating problems, my recommendation, look for buzzwords. We're working with ones that result in algebraic translations, but as a generality, look for buzzwords in the problem that we have been given. That's a huge indicator of, am I doing addition? Am I doing subtraction? Am I multiplying? Am I dividing? Where does the equal sign show up? Anything to that effect. So this entire chapter is designed primarily around getting comfortable with and doing more of this translation. And again, I highly recommend you guys take a look at, download this page, whatever you need to do with it to help you out with that. So as part of this, again, I can't emphasize this part enough. Read each part of the sentences, I got more of them, slowly and repeatedly. Mistaking a word to mean something else is an extraordinarily common mistake. And I'll put money on every single one of you at some point in time is probably going to make that mistake. And that's okay. The main thing is if you do make that mistake, okay, identify what did I do wrong with it? What did I assume that meant? And then look up what the correct version of that is or should be. So do not rush yourself. Take your time as you are going through these because all of this is designed to help us with the setup portion of story problems. Because ultimately we're going to get to story problems where you might have 2 or 3 different equations, and if you don't set them up and create the right algebraic expressions or equations that we need to work with, the entire problem is going to be wrong from the beginning. So do not rush yourself in this process. Remember that ordering does matter algebraically when translating statements. I think I've referenced this example a few times, but here's your bank account. Would you rather have $10 million and take away 5? Or you have $5 and now we need to take away 10 million. So make sure when you are reading and translating these things, what operation am I using? Making sure that I'm writing things in the correct algebraic order because, again, it absolutely matters. Not really much of a middle ground that we can go to on these. And the last part here before we get into some of the more specifics on this, when we are translating a problem, or we are doing a setup portion of the problem, that does not mean we are immediately finding a numerical answer. A lot of people want to go with, okay, I read the sentence, I read the paragraph, and now I need to be able to go right to the answer is 6 or 7 or whatever the answer may be, or they think the answer may be. And that's not the case whatsoever. All we want to do is just translate a problem out. We just want to say, okay, I've been given stuff. I have some buzzwords. I kind of understand what we're doing with this. I've read it a few times. This looks like it could be an algebraic statement based on what I've been given. Or this could be an algebraic statement based on what I've been given. But a big thing that people want to do is I've read it once. I need to know what the final answer is. And no, don't do that. Don't jump to that conclusion. Do not rush yourself. The biggest thing that kills people in the chapter 3 material with points is they just read it once and then say, I'll do this now. You don't want to do that. You absolutely do not want to do that at all. So again, I can't emphasize taking your time and doing this setup very, very methodically. Because this is essentially setting you up for either success or failure for the entire rest of the problem. So we've got a few of the buzzwords in here, again, identifying buzzwords that result in algebraic translations. So we've got a few of them in here. So if you ever seen the word add, sum, plus, more than, increased by, total, anything like that, those are all going to generally correspond with doing addition. You see subtract, difference, minus, less than, decreased by, those generally correspond with subtraction. Multiply, product, times, twice, double, generally going to go along with multiplication. And division, quotient, ratio, generally go along with division. And again, there's a more extensive list on this other page that I have given you guys. There's some more examples that go along with it as well. So I would take the time again, if you haven't done this, go download, take a look at, print out this page for yourself, because there's a lot of buzzwords in here that are going to help you out when you get into working with other algebraic expressions. I think the equals one is extraordinarily important, kind of like with the examples that we were going through yesterday, where you can kind of divide up an expression that you've been given. So again, take a look at that as we're going through problems today. We're going through translating these things. If you're wondering, okay, well, how is he getting this terminology or this statement? This is what I'm referencing, the lot of this. There's a similar page like it and a similar page like this in the textbook for 3.1, but I wanted to give you guys a bit more of an extensive one to take a look at as well. So let's go into, again, starter set with anything for that. So let's go into taking a look at and working on a couple examples with this. So all we're doing, we're told translate the following into algebraic statements. So we are not actually solving this for anything. We are not finding a final answer whatsoever. I believe a fair amount of the 3.1 homework is going to have you doing this. So make sure you are reading the question to see, does it want you to solve something, or does it want you to just translate something into a statement? So make sure you're reading those directions also, because that's a very good indicator of what you're going to be doing. Okay. So our first one that we've been given. Drew Brees, there was an average of 263 passing yards per game. How many passing yards does he have after T many games? Okay. So we're thinking, okay, so throwing the football, he's got some amount that he's passing every single game. If we were to use, we're going to take a step back from this exact question to see, okay, how could we generate an algebraic expression for this? Okay, so let's go through this on a game-by-game basis. So if he has 263 passing yards per game, how many passing yards would he have after one game? Well, that would be 263 times 1, because he's got one game that he's played. Okay, so that's 263. Well, how many passing yards would he have after 2 games? Okay, so that's 263 plus an additional 263. Or you could think of it as 263 times 2. Okay. How many passing yards would he have after 5 games? Well, we could add 263 together 5 times. Or we could say 263 times 5. Because we're assuming he is throwing that same amount every single time. So following this, okay, how many passing yards does he have after T many games? So if I list any number of games out that he's played, how could I determine how many total passing yards he has based on that? Well, based on the previous ones, we've done 263 times the number of games that he's played. So if I don't know the number of games he's played, I can leave that as an unknown. So I can have my final answer to this be 263 T, where a T is the number of games that he's played. So translating that thing out, where's my pen here? Come on. So for number 1, we would have 263T. Okay. So looking at number 2 then. Again, we're just translating the following into algebraic statements. We are not solving for anything. So looking at number 2, we're told 10 more than double a number is 6. Okay. So this is one, again, we've got buzzwords showing up in here. Where are they? What are they? As we have been given some of these problems. So buzzwords, I'm seeing more than, double, and is. So seeing some buzzwords in here, again, you do not want to rush your process with translating this. So is one of our very special ones that we want to take a look at and generally want to go with first. Is translates into our equal sign. So I'm going to have the first half of the sentence equals the second half of the sentence. So that is kind of divides this thing up into 2 parts. So something is something else. Now the really nice part about this is we have something is 6. So whatever the first half of this is going to equate to, this whole thing should equal to 6. So I have half my equation done. Half the equal sign is figured out. But now I need to figure out how to translate 10 more than double a number. Okay. So 10 more than. What operation do we think, think on it for yourself, or by yourself here for a second. More than. What operation do you think that's associated with? Addition, subtraction, multiplication, or division? Okay, I'll let you think on that for yourself here for a second. If you have that English to algebra page up right now, or you have that on a different screen or something for yourself, you're welcome to look at that. So more than is going to translate into addition. You can kind of see it hidden up here as well, but more than is going to work with addition, this thing. So I have something adding, oops, come on, and then double. What operation does double associate with? Addition, subtraction, multiplication, or division? So I gotta think on that for yourself here for a second or so. And doubling is going to work with multiplication. So I have something that's adding with something else, I have something that's multiplying with something else, and how do I bring all of that together? So I have 10 more than double a number. So if I have been given a number, whatever that may be, I first need to double that thing based on the wording. So I double a number. Don't know what that number is. I'm going to arbitrarily call that number n for a number. So I have double a number. So whatever that is, I'm multiplying it by 2. So double a number. And I have 10 more than double a number. So whatever 2n is going to give me, I have 10 more than that. So I'm going to be adding 10. So now we have 2n plus 10 is equal to 6. And let's reread the equation, or the sentence that we have been given, and see if our equation lines up with this. So 10 more than double a number, so I have double a number, and I'm doing 10 more than that, is 6, is equal to 6. 2n plus 10 is equal to 6. And we have our answer here. Okay? And again, as I mentioned earlier in the notes, ordering does matter. So make sure we're keeping track of that with how we set these things up for ourselves. Okay. I'm going to scroll down here a little bit just for the sake of having some room, because we'll write stuff in the space below here. Okay, so taking a look at number 3 now. So we're told the height of a triangle is 12 greater than the base of a triangle. Okay. The height of a triangle is 12 greater than the base of the triangle. And again, we're just translating this thing. So one of the nice parts about this, and again, I recommend you do this with any kind of a story problem, even if we're just translating, because I think it helps, let's make a visual of this thing. So I'm actually going to jump over to the whiteboard because it gives us a bit more space with that, but we are going to be referencing and working with number 3 here. So going over to the whiteboard. Come on, there we go. So we're told the height of a triangle is 12 greater than the base of the triangle. So let's make a visual of this thing. So I'm just going to make triangle here. Got a right triangle showing up. There we go. I'm going to label some parts of the triangle. Here's our height. Here's our base. Okay, just some basic labeling here so I know what I'm looking at. So now we've been given the height of a triangle is 12 greater than the base of the triangle. So we have our height, we have our base set aside here with our different variables. Now translating this thing, as we're reading it, the height of the triangle is, and we're going to stop there. Is, again, is our buzzword for an equal sign. It's going to divide our sentence up. So I have the height is, so that's going to translate into the height is, so we've just done the first half of our sentence, or expression we've been given. The height of the triangle is. That's all we have there. Now we're going to look at the second half of the sentence, essentially everything after the word is. 12 greater than the base of the triangle. So 12 greater than the base of the triangle. So again, think on it to yourself. I'll give you a second here. Buzzwords there. Greater than. What operation do you think is associated with greater than? Addition, subtraction, multiplication, or division? And in this instance, it's going to be addition. So 12 greater than the base value. If I know what the base is, 12 greater than that, I'm adding 12 to that thing. So height is 12 greater than the base. So if I know what the base is some value, 12 greater than that. So I'm taking the base and I'm going to be adding 12 to it, and that is going to tell me what my height is. So now we have an equation here. Let's reread the statement that we've been given and make sure it translates correctly. The height of a triangle, H, is, equal sign, 12 greater than the base of the triangle. So the B plus 12. So we have this thing translated correctly. Okay. And then this is an instance where a lot of people will take a look at this or be given a problem like this and say, all right, well, I have the height and I know the base is 12 more than that. So the base has to be this number, which means the base is this and the height is this exact number that we have here. And it turns out that for number 3, it is absolutely impossible for you to get a single numerical answer out of this. You do not have enough information to do that. All you can do is set up a statement, an algebraic statement like we have here. If you were going through and working this on the homework, on the test, and somehow you worked out to get B equals, let's say, 10 and H equals 22, my question to you is how? Because there's not enough information that's given on that front. So again, the emphasis of this section, we'll go through a few more examples with it, but the emphasis of this section is to just set up story problems. Just writing out an expression or an equation for ourselves. We are not looking necessarily for final answers. Okay. So I'm going to jump us back to our notes, and then we'll come back over to the whiteboard for writing these things out, because I forgot how little space is written at, or I have on the PDF. So we'll go back and forth there. So looking at number 4 we have here. The sum of two numbers where one number is 8 less than the other. Okay, so kind of a weird setup or sentence that we have written out there. So again, read these things multiple times if you need to. The sum of two numbers where one number is 8 less than the other. Okay. So we have some stuff adding together, it sounds like. We might have some things, we know something about the relationship between the two numbers. See what we can do with that. Write this thing out. Okay. But we are working with number 4. Let's go back to the whiteboard and kind of go through a way of analyzing and setting this thing up for ourselves as necessary. So the sum of two numbers. So I have two things that are going to be adding together. The sum is a buzzword for addition. So the sum of two numbers. I don't necessarily know what those two numbers are. So I'm going to have essentially two unknowns. So we can choose for ourselves what we want to label those as. I am going to choose X and Y. So I don't necessarily know which one's larger, which one's smaller. Kind of our choice there. So we have been told the sum of two numbers. So we're going to have some multiple steps we need to go through for this. So the sum of two numbers. Sum tells us I'm adding things together. Okay. So I'm going to have X plus Y. Okay. So it's the sum of two numbers. Fantastic. Where one number is 8 less than the other number. So this is the instance where we're writing these things out. Okay, I have been given some information about these numbers, and I can start by writing something, which is good. But now I might need to go back and revise the expression that I have written based on other data or information in the problem, which is fine. So we have our initial expression written out for ourselves, the sum of two numbers. Fantastic. But now we need to add in the more specific information we've been given, where one number is 8 less than the other. So that's the second half of this equation that we have. We need to figure out what is that going to look like. Now we have not been told whether X or Y is the larger or smaller number. We arbitrarily made up numbers in that for our variables in that front. So what's nice about that is we can choose for ourselves which one we want to be larger and which one we want to be smaller, and set up and write our next part of the equation accordingly. So we've been told one number is 8 less than the other. So I'm going to say that Y is going to be the smaller one. So one number, we're just going to arbitrarily choose Y. One number is, so again, our buzzword of is, that's our equal sign. So one number is 8 less than the other. Less than is a set of words, buzzwords for subtraction. So 8 less than the other. So the question is, how do I translate 8 less than the other into an algebraic statement? And the question that I have for you guys, and again, I'll write this out, think on it on your own here for a second, but is that going to translate into 8 minus x or x minus, minus 8? Remembering again that order absolutely matters with this. So 8 less than the other. Take a second and think on that. So translating this thing, 8 less than the other. In this instance, we are going to be using and writing this out as our bottom one we have here, x minus 8. Whatever my original thing is, I'm taking away 8 from it. It's 8 less than that. So really, we have that written out there. So our y value is the same as saying y equals x minus 8. And the last thing that we do at that point in time is we are bringing everything together as a single equation. So I was told the sum of two numbers where one number is 8 less than the other. So now I have y written in like this, and I'm going to put that in for y up here in my original equation that I created. So my original expression now is going to look like x plus x minus 8. So we see in our blue, here's our y. We've got our y value here. We've got a y value down below. Use this here. We've got a y value shown up here. We have another way of writing out y, and then this is how we translate it all as a single sentence or a single expression. Okay. So again, taking these things apart, solving them piece by piece, not trying to do all of it at once. The goal is ultimately to be able to do all of it at once and translate it fairly quickly, but we can't do that if we don't have a solid foundation of how to translate these things as a generality.
So is it x plus x minus 8, or is it y plus x minus 8?
And our final answer is going to be this one here.
But there's no
X.
y.
So that other number that we have is written in as inside of parentheses. And that's how we leave it translated for our final answer there. We'll come back to this one. I do want to get to our last two. So if you do have any further questions with that, we will come back to it. But I do want to get to the last two because we've got some fractions showing up and then a couple other ones. So if that doesn't answer it, then we'll come back to it here at the very end. So we're going to take a look at number 5. Stuff here. Jumping back to our notes. So looking at number 5. 4 less than 1/3 of the number y. So 4 less than 1/3 of the number y. Okay, so this is one we're going to be translating in here. I do not see the buzzword of is showing up in here at all, which means we are not going to be having an equal sign, which means this is all we have to work with. Nothing is going to equal anything else. We're just going to have an algebraic expression showing up. So jumping back to our whiteboard, but this is referencing you guys here. This is the number 5 that we're working with. So we've been told 4 less than 1/3 of the number y. So I've got y showing up in here somewhere. Now buzzwords, less than and 1/3. Those are the two that are standing out to me. So we're going to let you think on it for yourself here for a quick minute. Less than. What operation does less than associate with? Addition, subtraction, multiplication, or division? And just like we did with our previous example in number 4, less than is going to be associated with subtraction. So I'm going to have something minus something else. I don't necessarily know the order at this point in time. And order absolutely matters. So we need to make sure we have it written incorrectly. So 4 less than 1/3 of the number y. So 1/3. It's going to tell us that we're going to have either a division showing up or we're going to have a fraction showing up. So 1/3 of the number y. y is we're assuming it's some number, whatever it may be, positive, negative, whole number, decimal, integer, who cares? It's a number. So 1/3 of y. You have a couple ways you can write this out. 1/3 of y could be written as y divided by 3, or you could write it as 1/3 y. I'm indifferent as to which one you would like to use. I personally like having the fraction out front. So for this, I'm going to write it using 1/3 y. But again, nothing wrong with writing this out as y divided by 3, or y over 3. It means the same thing. So with this, we're told 4 less than 1/3 of y. And again, ordering matters with this. So I have subtraction showing up in here. So the question is, am I going to have 1/3 y minus 4, or 4 minus 1/3 y? So what you guys think on that here for a second, based on the previous example that we did, based on the wording, based on the fact that ordering absolutely matters with these. Think for yourself is going to be the first one. So it's going to be option A. It's going to be option B. I'll give you guys a second here to think about that. So the correct way that we are going to be translating this thing is using our first one that we have here, option A. 4 less than 1/3 of the number y. So if I have 1/3 of the number y, I'm taking 4 away from that. I have 4 less than whatever that value is. So again, the ordering, especially with subtraction, absolutely matters with this. So make sure when you are going through and looking at these things, again, that English to algebra page I have up there and available for you guys, take a look at that thing, print it out. It's invaluable, especially for these ones where we have subtraction showing up. Okay. So we'll take a look at our last example that we have here. So jumping us back to our notes, then we'll come back here. So number 6. How many inches are in m feet? How many inches are in m feet? And again, all we're doing is translating. We're not actually solving this for a numerical answer. It is impossible to find a numerical answer to this. So jumping back to our notes, or our whiteboard, I should say. So first off, we need to know, okay, how many inches are in 1 foot? So we have 12 inches in 1 foot. Okay. So if we were to kind of start with some baseline numerical examples. So if we have 1 foot, how many inches are in that? Well, it's going to be 1 times 12. So give us our 12 here. If I have 2 feet, it's going to be that 2 times 12 gives us 24 inches. If I have 3 feet, it's going to give me 36 inches, and so on. So the question becomes, if I have m many feet, how many inches are going to be in m many feet? So if we're to kind of follow this out, if I have m for feet, then what's my total inches going to be? Well, we're assuming m is going to be a number of some kind. Positive, negative, 0. I mean, it's going to probably be a positive. So whatever that number m is going to be, all I'm going to be doing, just like the rest of our pattern, is multiplying that by 12 inches, and that's going to give us however many inches are in that many feet. So our final answer for this is just going to be 12m, where they have to give us the number of feet that we have, and then we can determine how many inches come out of that as well. So again, this is just one strategy that you can go through and use to translate these things. I think it's kind of nice with some of these ones where we're just multiplying things together, but again, there's multiple ways that you can go about organizing this for yourself and setting that up. Multiple ways to think about these things, but we should ultimately be getting to the exact same answer as we're going through this. Okay. So that is everything that I wanted to go through for today with the examples that we have. So again, these are the 4 that we have written out here. It's kind of all over the place, so apologies on that front, but got that there. So this is, again, everything for 3.1. The 3.1 material is not going to be on test 1. You will be doing some translations, but we've already worked with some of that in chapters 1 and 2, so it'll be more geared towards the chapter 1 and 2 types of translations over anything else. So I'm going to end our recording here, and then if you have any questions, we'll go through those and then take care of things from there.